Right. So in the previous session we have seen about how to define vectors for fields like electric field, radial vector. So we have seen how force between two charges direction can be decided. Right. So now we will see some basic concepts of vectors. Basic concepts of vectors with some more detail. Okay. So a vector is defined as any physical quantity with both magnitude and direction. Both magnitude and direction. So it is represented by like this, or with an arrow mark on overhead, or with a cap, or with a bold letter. These are three possible ways of representing a vector. Okay. So let's say the most conventional example that we see for vectors is distance and displacement. Let's say somebody's house is like this. When somebody has to travel upwards and then right, again left, again right, again left. To reach from point A to point B. Let's say this is the so then distance is, let's say this is 1 unit, 2 units, 1 unit, 2 units, and 1 unit. So total distance is 7 units. Whereas the displacement is given by the shortest line between A and B. So you have to calculate the diagonal length, so that can be calculated. So now the major issue is, here actually we are tagging the direction information also. Actually, while traveling from A to B, let's say you are starting from A, traveling 1 unit straight, then you're taking right and traveling 2 units, again left, traveling 1 unit, again right, traveling 2 units, again left, traveling 1 unit. So whatever distance you are talking about is now tagged with direction information also. Then what is it called? దాన్ని ఏమని పిలవాలండి? ఇక్కడ కూడా మనము ఈ డిస్టెన్స్ అనే మాట చెప్పేటప్పుడు లెఫ్ట్ రైట్ అని డైరెక్షన్ ట్యాగ్ చేస్తున్నాం. సో ఈజ్ ఇట్ కాల్డ్ డిస్టెన్స్ ఆర్ డిస్ప్లేస్మెంట్? So let's say this is north, this is east. So maybe while talking about vector, you may call it as a northeast direction. That is okay. But what about this? So this is called directed distance. So this is another kind of physical quantity. This is not a vector. This is not a scalar. It can be considered as a special case of a vector. It is called directed distance. That quantity, that physical quantity, is more useful, especially in computer algorithms, graph theories, like in your social network, friend sessions. So you'll be seeing your nearest friends, next near friends, So your first level of friend circle, second level of, I mean, your friend of friend kind of. So all these friend suggestions will use this directed distance concept in computer programming, especially in graph theories. So people will be calculating, let's say, first nearest neighbor, even if it is diagonal or so there are various definitions for that directed distance. Manhattan vectors, I mean, there are several kinds of that. That is not a point of discussion now. I mean, I'm just mentioning it because while describing distance information also, you are tagging direction. So that is a different physical quantity which we do not use most often in physics. Okay. So now coming to this vector, the basic definition of vector is as long as you keep the direction and magnitude of the vector, you can, the most flexible point is you can shift the vector to anywhere. That is most useful while calculating, while doing any calculations using vectors. Let's say this is a vector. So as long as you keep the direction and magnitude, you can shift it to anywhere. So this is also called B vector. Okay, so that is a simple advantage with vectors. So we can use that property to explain several concepts in vector algebra. So now the first thing is angle between vectors. Let's say, I mean, if you have two vectors, what is the angle between these two? Let's say this is A, this is B. I mean, most often this is the angle between the vectors. Let's say, if at all, if your vectors are like this, if your B is like this, then what is the angle between? Is it the angle or something else? So the definition for angle between two vectors is it is the smallest angle between any two converging or diverging vectors. So to measure the angle between the vectors, you must ensure that two vectors are either diverging or converging. Let's say this is the type of the vectors. Then that can be defined as angle. So if the vectors are not a converging pair or diverging pair, you have to develop them by using the property of shifting of vectors. Okay, so let's say if you are given this pair, one is a converging vector, another is diverging vector, then you can generate both the diverging pair let's say by shifting B downwards. Then the smallest angle is this one, and you can even shift A upwards. Let's say B is like this, you can shift A upwards, so that, I mean, if you shift A upwards, otherwise if you shift B downwards, you get the same result. Another possibility, if B is like this, you can shift A backwards. This is the angle. When it is same as when two lines cross each other, the angle on the opposite sides will be equal. Right? So these are the possibilities for angle between two vectors. So angle between two vectors will be varying between 0 degrees to 180 degrees. If it is more than 180 degrees, you have to take the other side. I mean, let's say this is not the one, you have to take this. Whatever smallest value of angle between the two vectors is considered. So that should be measured only after you shift the vectors and get a converging pair or a diverging pair. So that's about angle between two vectors. What about, if you have only one vector, in your reflection, refraction kind of concepts, you have only one vector. In that case, you have to consider one reference direction. So that reference direction could be either a tangent or a normal. So during reflection and refraction, we consider normal. So that is called co-latitude. Co-latitude. So this angle is called co-latitude angle. So it is the angle made by the given vector with the normal to the surface, with a perpendicular line to the surface. Whereas in your Bragg's law, you are measuring angle made with the surface. So this angle is called latitude angle. So it is the angle made with the tangent to the reference surface. So this kind of definitions are used mostly in geography, right? When you take Earth from equator, so if you take equator as a reference line, latitude angles are defined starting from equator. This is 0 degrees, 30 degrees, 60 degrees, and finally this is 90 degrees. Latitude is the angle made with respect to the tangent to the surface. So we are taking equator as a reference line, and from there we are measuring the angle made with the tangent to the surface. So when you reach the pole, the tangent line will make 90 degrees angle with the tangent at equator. Okay, so they are latitudes. So perpendicular line to that is called co-latitude. Okay. So it is the angle made with the normal to the surface. Right? Next one that we come across is components of a vector. Let's say you are given a vector like this, and this is your x direction and y direction. Then let's say this is the angle made with x-axis. Angle made by the vector with x-axis is theta. Then the perpendicular component is given by sine theta. So it is called a sine theta. And the component perpendicular to that is given by a cosine theta. Okay. So the same as latitude and co-latitude. So here it is sine theta is the normal component and cosine theta is the tangential component here. So you can confirm that. Let's say if theta is 0 degrees, cos theta is 1. So when the vector A makes 0 degrees angle with x-axis, x component will be maximum. So x component is A cos theta and y component is A sin theta. So when theta is 90 degrees, this y component gains maximum value. So when theta is 90 degrees, x component becomes 0 and y component becomes maximum. Okay, so that is what we see by the nature of those sine angle and cosine angle. Okay, so they are the components. So now we come to the dot product of two vectors. Otherwise, first of all, we'll see the addition of two vectors. So for adding two vectors, you have to connect the vectors from head to tail. Let's say you are given two vectors like this, A and B, and the angle between them is theta. Then to add two vectors, you have to generate or you have to connect the vectors head to tail. So you have to shift the vector B so that you will get your vectors get connected head to tail. Then the diagonal line or connect the starting point of the vectors and end point of the vectors. This is called A plus B. Sum of those two vectors. So the rule is connect vectors head to tail. Then join first tail to last head. So if you have more than two vectors to add, let's say you have three vectors like this, then what you have to do, you have to join them like this. Let's say this is A, B, C, then it is A, B, C, somewhat like this. Then this is A plus B. So if you have more than two vectors, even then you have to join all the vectors from head to tail. So let's say if you have different sets of vectors, like if your names are different, like this is A, B, C, D, then what to do? You have to join them in the order of increasing angles. So A, D, C and D. So you have to join the vectors in the order of their increasing angles. And then join the first tail with the last head. So that is the result of addition of all the vectors. So basically order doesn't matter. Let's say if you are starting by adding A plus D, instead of A plus D you can even add A plus B. Let's say you are adding A plus B. What is the result? So you have to shift B to here. So this is B. So this length is A plus B. So from there you have to add your C vector. So whatever may be the order, if you join all the vectors, the resultant will remain the same. Okay, so that is the advantage with this basic definition of shifting of vectors. So as long as you keep the direction and magnitude same, you can shift the vector to anywhere. Okay, so that is about addition of vectors. Then coming to subtraction of vectors. So if you want to subtract a and b, I mean a minus b, to change the sign of the vector, you have to flip the vector downwards. So this is a minus b. If this is b vector, mirror image of that will give you minus b. Okay, now you add these two vectors, a and a plus minus b. Gives you a minus b. So how to add those two? You have to shift the vectors head to tail, or connect them head to tail, right? So you keep a like this, and you have to shift b. Which way? So this is a minus b. You have to join the vectors head to tail. Your second vector is already acquired a negative sign, so you just have to add them. So first tail to last head, so that is a minus b. So in other words, this is a minus b. Same magnitude and direction. Okay. So what are you doing to calculate the difference of the two vectors? So you are joining them as if you are measuring the angle between them. So you are generating either a converging pair or diverging pair. Then your result should be starting from negative vector to positive vector. You have to draw a line starting from negative vector to positive vector. So when you are calculating a minus b, you have to start from b and end at a. Let's say if you want to calculate b minus a, what direction will it be? Let's say this is a, this is b, and you want to calculate b minus a. What to do? You have to flip the vector a. So b remains as it is, and a, for a you have to take mirror image. So this is b and this is minus a. Then you have to add them. For that you have to join the vector side to tail. So this is b, this is minus a. So that is b minus a. So magnitude wise it is same as a minus b, but with a negative sign, opposite. So you have to start from tail of negative vector and end at head of positive vector during subtraction. So here also whatever. So what are you doing here? So b minus a is, this is b minus a. So what are you doing? You are starting from negative vector and ending at positive vector. So that is subtraction of vectors. Then comes dot product of two vectors. Okay. Okay. So now we'll see dot product of two vectors. So to calculate the dot product, and let's say you're given two vectors A and B. What you have to do is, so A dot B is given by AB cos theta. So you have to take the projection of the second vector onto first vector. So if you place a mirror along A, where do you find the image of B? So the component of B along A should be considered. So if this is angle theta, the component of B along A is B cos theta. So you have to multiply that with A. So to get the dot product of A and B, you have to take the component of B along A and multiply. So it is just a number. So this is just a number. I mean, you won't get any direction for that. Let's say if you want B dot A. What is B dot A? So for that you have to take the component of A along B. So this is A cos theta. So B times A cos theta. So magnitude wise that number will remain same. So this is just a magnitude. Okay. So this is a scalar constant. So A dot B is equal to B dot A. So next one is projection. Projection of a vector. Let's say you are talking about two vectors. Let's say you want the projection of B along A. So that can be written as a projection of B along A. So this is given by A dot B. A dot B means what? It is AB cos theta. You get the magnitude of the projection, and then you have to assign a direction to that. So the direction is along A. So by definition it is a projection of B along A. So you have to take a unit vector along A. So it is given by A by modulus A. Modulus A is the magnitude of the vector. So let's say if A has the components x and y, magnitude A is x square plus y square. So that is a projection of the vectors. So this projection of the vectors is most useful while orthogonalizing vectors. I mean, if you are given some set of vectors A, B, C, which are not orthogonal, I mean that is the most essential activity in quantum mechanics. So in quantum mechanics, all vectors that we consider must be perpendicular to each other. So then only their dot product will be 0. So we must ensure all the vectors are independent of each other in quantum mechanics. So if you are given some set of vectors which are not perpendicular, let's say A, B and C, you can generate a perpendicular set of vectors from that. Okay. So I call them as let's say V1, V2 and V3, three vectors. So this is V1, V2, V3. So you can generate a perpendicular set of vectors from any set of given vectors. And we use the concept of these projections. Okay. So I call my V1, U1 as a first vector in the set. I consider V1 as my first vector. Now coming to u2. u2 is the second vector perpendicular to u1. So how to generate a vector perpendicular to u1? So I take v2, I take the vector v2 and subtract the component of v2 along u1. So if I subtract the component x component, I will be left with only this one. If I subtract that, I will be left with only y component. So I am taking the vector v2 and resolving it into two directions, one along x direction, one along y direction. So I am subtracting the component, so projection of v2 along u1. So I will be left with only perpendicular component. So the resultant vector v2 minus projection of v2 u1 is now perpendicular to u1. And third vector is now I had to generate it from v3. So from v3 I had to subtract both the projections. So projection of v3 along u1 and projection of v3 along u2. So this means what? You have to take the dot product of u1 and v2. This is the magnitude, and you have to take the direction. The direction is what? u1 by magnitude u1. So this is the projection of v2 along u1. So like that you can generate completely perpendicular set of vectors from any set of given vectors. So this is called Gram-Schmidt orthogonalization. Okay. So rest of the details we'll see in the next session.